Okay, welcome to my math cards. I want to give you some kind of an overview. It's different, I think, and so I want to give you an idea of what it's all about. So, what are they and why? So, they're cards, nothing new about that, but they've got maths on them, nothing new about that. Um, the issue is that you can make multiple sets and the students pick the set that they want to work on and they can play together and they're actually doing skill and drill but in a social, playful manner. So student voice, they actually think they're cool. So that helps in the classroom if the kids think maths is cool. No brainer, right? So with all of these cards, they're kind of made up as a matrix that you can link them in two different ways at least. So for example, here we have they're not equivalent expressions, but all of the expressions are two variables and they're partially factored. So you could say for two of these, if you were playing Snap, you could snap them by saying they're the same format and they're two variable expressions. So the literacy comes in. If you were playing a set type game, you could call any three of these a set, so long as you can articulate the reason. So we have wildcards, and then you can be creative about what a set is. So here we could say, well, the next one, the sequence, is 8, A plus B plus C plus D. But my daughter pointed out, well, 8A would be the first in the sequence, which is also valid. So it would be like a one variable expression or a four variable expression could complete that set. So here you are getting to a more capable mathematician who's not just looking at the colour, they're thinking a bit more deeply. So the cards work quite well with differentiation. This is another kind of set in that same set of cards where you could have all the expanded ones together that are quadratic and call that a set, or a crossways you've got equivalent expressions. Different set of cards, parabolas. The thing here is I've kept the vertex the same, changed the shape. So a snap could be for that top row. The snap or the set could be they've all got the same vertex. You might dictate that they should all be positive rather than like upside down, if you like. And basically it's for the students to work out and discover and argue what is a valid set. You can see here we've got different sort of wildcards. So we've got all the parabolas with all the different shapes, all with the same vertex here. So those are a card each, but that's sort of a specific wild, as is this. We've got some like hint cards, teaching cards, and here they've got all the same shape, but the different vertexes. So the wilds are not completely wild. They're trying to get the students to think. They're thinking cards. How did I make them? I went to makeplayingcards.com. I've currently got 4 sets that I want to build on, and one of them is based on the Prime Climb, which is what actually started me off with all of this, because the students were playing Prime Climb once a week for about 8 weeks, and their results went up, their attitude changed, and I thought this is worth investigating. So that's what they look like on Make Playing Cards. So on the site, you can actually see the backs of them, the fronts of them, and you can see exactly what you're getting. These are just some of the cards on the Prime Climb one. So I took Prime Climb, notice that, for example, 5 is blue, but here 5 times 5, the blue is the number. It's not the size, therefore it went really well to algebra. It just lent itself. So if these two cards came up in Snap, someone could say, well, x equals 7, therefore I can snap that. And again, it's thinking very flexibly about the numbers. If we've got this one here, and say we had 21, for example, you could go x equals 3, so that's a snap. If we have these two, the 32 and 64, we could say 32 times 2 is 64, therefore it's a snap. So it's up to the students to decide what's a valid snap and what isn't. Here we've got some examples. So here, the purple actually cancelled. So we left with the 2 orange, 2 times 2 is 4. So that's a bit of a trick because people are matching the colours and then they realise, no, that cancels. So we've got fractions in amongst it. Here again, the purple cancels. The purple doesn't cancel, the 3 cancels. And we're left with the purple, so we're left with 7. So that could be a pair, the 7 and the 21 upon 3. But also 7x could be in that and just say x equals 1. And for the 49, we could just say 7 times 7 is 49, so I'm going to link those two. Here, for 81, we could say x equals 3. And if we've got the 25 and this one, we could say x squared equals 5, or x squared equals plus or minus the square root of 5. So you could get fancier given your mathematical ability. So the big thing with the cards is the students make up the rules, the students make up the games, the students find the connections. Of course, you are giving them ideas and you ultimately help them make decisions. This game is online called Set. It's also a physical card game. Playing it online might give you an idea of kind of how I'm working. It's a similar thing. I actually found this game after making the cards, but it's a similar kind of idea of how to form sets. So it's actually, I quite like this, it's cool. Why? So we've kind of covered what we're doing with the cards maybe, but the why, I'm looking at peer mentoring, the Tuakana-Taina kind of relationship, but I'm also looking at the fact that children like to play. They find maths dry and boring. So it's like that social connection that I feel I'm harnessing, their relationships with each other, their ability to learn from each other is the cards are kind of a vehicle for that to happen. I think I'm onto something, time will tell. This is just a little bit about my kind of research base. So I really like Dylan Willems' concept of activating the students as resources for each other. And I've really tried doing that and I found it quite hard to get traction, but the cards seem to get instant traction on it. With the 4 classes, I basically got 100% buy-in. There's possibly 1 or 2 students a little bit on the edge of it, but they're actually mathematically competent, funny enough. The students that are struggling, they take to the card games no problem at all. Of course, there's wild cards, so everyone's included, even if they really can't do the math. So it's sort of a way of getting students joining in. So we really want a supportive classroom community, away from the teacher being in charge of a group of individuals, activating the students as resources for each other inside and outside the classroom, and developing leadership with all the students. This is the dream. A little bit of research with the decline of play, the decline of play in our society, given that we don't let them sort of play outside and we have the technology, so they're kind of connecting with each other with technology, but they're not actually face-to-face debating, arguing, laughing. And I think if we can bring that into the maths classroom, it's got to be a winner. So why? Reduce anxiety, build resilience, develop social skills, build mathematical connections, skill and drill, but it's fun, to attain it in a playful way, motivation and engagement. And so why not give it a try? The end. And I didn't, oh,